Welcome to Carlton's Math Corner. Today we are going to continue our study on integers. At this time, please make sure that you have your math journal, your vocabulary packet, and something to write with. Today, our target, or one of our targets, is I can compare integers using inequality symbols. Well, first of all, let's remind ourselves what an integer is. An integer is a whole number, or which is basically a counting number, and its opposite. So whole number of 2, the opposite of that would be -2. They're equal distance from 0. Inequality symbols, remember, are symbols that we use to compare two numbers. So for instance, this first one, they kind of look like, the mouth of an alligator. But this one is less than. And the way that I remember this one is, first of all, it has the point coming first. And so, or if you turn this symbol, if I turn it just a little bit and kind of tilt it, it actually makes the letter L. And I just remember that as L for less than. And then the other symbol is greater than. The mouth comes first. Now, I know in elementary school you guys learn that the mouth always eats, the larger number. Well, very, very true when we're comparing numbers. And we are going to always have that mouth facing, and I'm talking about this open space. We're going to always have it facing the larger integer, and that is true. So let's look at some problems. First of all, these are all different types of integers. Some of our integers, and I actually threw in some numbers that are not integers, and we'll talk about those in a moment. But these are not integers because they have actual place values that are beyond the decimal point. Integers don't have any place values beyond the decimal point. But I wanted to throw them in there because we actually can compare any type of number, but our main focus is going to be these numbers that are above. So all these numbers, these are integers because they're counting numbers, or they're the opposite of them. And these, we just call them rational numbers, or we say that we could say they're decimals. We'll just call them decimals. But we could still compare them. And so if we look at this, let's start off with these two integers. We have -8 and -4. First of all, we need to ask ourselves, which one's larger? And when you're dealing with negatives, remember, the further you go away from 0 in the negatives, actually the smaller it gets. I know it looks like it's getting bigger, but it's getting smaller as we get further from 0. So which one of these numbers is further from 0? The -8. So what that means is the -8 is actually the least number. The -4 is actually the greatest number. And I know that looks so weird because the 4 does not look greater than 8. But remember, with integers, it's kind of like, I think of negatives as like you owe somebody money. Well, if I owed someone $8 compared to owing someone $4, well, actually, I would have more in my pocket if I didn't have to owe somebody more money. And so this right here, this -4, I'm almost done with owing, I only owe them $4. So this one is a greater number. And what that means is the mouth is going to face the -4 because it's the greater one. The alligator is like going to eat that bigger integer. Or the other way I like to think of it is, if you give 1 point to the least number, and the greater number we'll say is the winner, and it gets 2 points, if I connect those dots, I actually create the inequality symbol that I'm looking for, and the mouth is facing the bigger number. And what is this inequality symbol called? Yeah, this is a less than symbol. So if I read this, it says -8 is less than -4. Is that true? Yes, it is. Okay, so how about the next one? +5, -1. Which one's bigger? Yep, a positive is always larger than a negative. And so no matter what, remember my least number, it gets 1 point because it's the smallest. My bigger number gets 2 points, and the mouth is going to face that bigger number. And so this is actually reading 5 is greater than -1. How about this one? -10 and -3. Which one's bigger? Yeah, -10 is because remember negatives, the closer they are to 0, actually the bigger they are. And so that mouth is going to face the 10, and that's the greatest. Now let's look at some larger numbers. These are positive integers. Now you need to determine which one is greater. Now the way that I do this is I actually like to line up my numbers. So like if I put 6256 and I put that on top of 6526 and I look at the numbers, these two, we start on the left side. If the first two are the same, then we cross them off and we go to the next two. Is there a number well, first of all, these are different. So which one's bigger? Yes, this one, because the 5 is bigger than the 2. So right away, this one becomes the greater number. So it's going to get 2 points, and this one's only going to get 1. And so really, in between them is going to be a less than symbol. And the same thing is true for the next one. If I put 13478 and 13748, if you notice, these first two numbers are the same, so I cross them out. And this row, they're different. And so which one's bigger? The 7. So that means this 13,748, that is the one that gets the 2 dots, and this one gets the 1 dot. And so it is, again, a less than symbol. Now, we're going to look at, I just wanted to throw these in here. I know we're only dealing with integers, and that means no decimals, but I want you to see that it is very similar to actually working with whole numbers. Because if I still write out 6.356 and I write out 6.536, even if I just ignore the decimal point, I mean, it's the same as writing out like this or writing it out like this. I'm still comparing, like if these two are the same, I cross it out, and then I look at the next two, and oh, right away, the 5's bigger. And so actually this one is the bigger one, so it gets 2 points, and this gets 1. And so I get a less than symbol. So even working with decimals, like even though they're not integers, we just call them rational numbers. They're just in that category. Like there's still something that we can compare. It's very similar to what we're doing right now. And our last one is 1.3 or 238 compared to 1.321. And which one? Well, it looks like the 1s are the same and the 2 and the 3 are different, so my 3 is bigger. So again, it looks like less than symbol. Now, we're going to do actually another target that is similar to this, and if we can compare integers, then we can also order them from least to greatest or greatest to least. And so it's kind of like, you know, the whole history of gaming consoles. When we look at a timeline, they always put them in order. I mean, if you look at these times, these are all in order. And so what they did is they took all these integers and they put them in order from least to greatest. And that's always how a timeline is because we're dealing with time. Time always starts in the beginning, and it always moves forward. And sometimes, though, in mathematics, we don't go always from least to greatest. Sometimes we go from greatest to least. And we could actually switch this timeline around if we wanted to and start off with, close to present day and then go backwards if we wanted to. But in this, usually with a timeline though, we always start in the past and we move to the future. And so we are going to do the same thing with integers. And what I want to do is I want to look at this list of integers and let's talk about how do we put this list from least to greatest. Okay, so we're going to put them into two categories, and here are the categories I came up with. So if we're going to separate them from negatives from the positives, and then we're going to start ordering them. Now remember, in the negative category, the bigger the number looks, that means the further from zero it is, and that means that it is the least number. The opposite is true when we're in the positive side. When in the positive side, the bigger the number looks, the greatest the number it is. Like it is bigger, okay? And so when you look at the negatives first, let's figure out which one is the least. Well, if I look at the first category, I can actually tell right away which one is the least because this one has 200 and this one is 100. And this one doesn't even have a hundreds place. So that means this one is closest to 0. So it's definitely not the least. But the negative 232, it is definitely the least. And then the negative 132 would come second after that. And so it actually worked out where this order that I had it in, it just happened to be correct. Because if I leave this and I keep it going, this is the least number. This would be the second least. Then this is getting closer to 0, so that would be the next one. And now we need to figure out, okay, well, what about the positive numbers over here? Are they also in the same order? Are they least from greatest? Or least to greatest? Well, okay, so let's start off with these two right here. I notice that they're in the 100, like this is 102, this is 120. So I can't compare them using the ones. But if I look at the next two digits, the 0 and the 2, I could tell which one's the smallest because this one's 0 and that one's 2. So actually these two are also in the correct order. Pretty amazing. If I keep going, if I compare this 376 and then the 2,564, would you agree that 376 is smaller than the 2,564? Yes. And actually 300 anything is bigger than the 100s. So we're still in the right order right now. But look at these thousands. Are they in the correct order? Well, the 2's are the same, so I can't compare those, but look at the next two. Actually, the 5 is bigger, isn't it? So we need to actually, I'm going to switch this order and bring it up and bring it below. And actually, now that looks correct. And so if I look at this, we have least to greatest, and everything looks good. Nice job. What I would like you to do is actually, I want you to try comparing numbers, and I want you to order these integers. There's two sets. There's this set and then this set. And you are actually not going to go least to greatest. You're going to go greatest to least this time. Okay? Okay, so give it a thank you for joining me at Carleton's Math Corner. Have a great day. See ya.